circular ring, right, which is wound with wires, right? So this is called as a toroid. Called as a toroid. So we'll pass the current through it. Let us see what will be the inductance that is taking place. Inductance value again. Okay. What is the value of substance V? V is equal to mu Ni divided by 2 pi r. How did I get this? How did I get this? How did I get this? What is the expression for V? V is equal to mu H. So mu into H is Ni by 2r. So V is equal to mu into Ni by 2r. Clear? Right? Take it out. So N5, the total flux linkage is given as N5, that is N into B into A. How did I get B into A? Because flux is equal to flux density into area of the cross section. Is not? So N into B into A. Right? So we have to get as NPA is equal to N into mu Ni. B value comes to 2. Okay, here will be Ni divided by 2 pi r. 2 pi r into A. Right? So what will be the area of the cross section? Area of the cross section. N into mu into Ni divided by 2 pi r into A. Okay? Right? So that is equal to N squared mu I divided by 2 pi r. 2 pi r. Taken? Mu into N square into I into A by 2 pi r. A is there, no? So into A divided by 2 pi r. What is the value of L? Sit down, the last row, that boy get up. What is the value of L? The next one, yes. Stand up. The last class we have seen, what is L? L is given by formula, what is that? General formula. Total flux linkages divided by total current. So L is equal to total flux linkages divided by total current. Total current. So what is the total flux linkage given? N squared mu IA divided by 2 pi r, right, into the total current is given as I. What can be cancelled? I can be cancelled. So I and I will be cancelled. We find it as N squared mu A divided by 2 pi r. This will be the inductance of the solenoid. Sorry, inductance of a toroid. Okay? What is the formula for the inductance of a toroid? N is equal to N squared mu A divided by I.
Solenoid example.
Mu into N squared A by 2 pi r. Sorry. Mu into N squared A divided by 2 pi r. This is for a toroid. Is it clear? Any doubts? Next, for a toroid with n number of turns, and height as h r1 be the inner radius and r2 be the outer radius. R1 is the inner radius and R2 is the outer radius. Then the inductance is given by L is equal to mu n squared h divided by 2 pi r mu n squared h by 2 pi r into ln of R2 by R1. R2 by R1. I am repeating, for a toroid with n number of turns and h as the height of the toroid, R1 as the inner radius and R2 as the outer radius. Okay. L is given by mu n squared h divided by 2 pi right into ln of R2 by R1. Okay. Somebody can give me the answer. What is that? Mu n squared h divided by 2 pi right ln of R2 divided by R1. This finally can write. Okay. Clear? So this is about here. What is that? Inductance of a toroid. Okay. Now we move on to the next one. Suppose they are giving the inner radius is A, outer radius is B. What will be your formula?
B
We are
by
again
A.
indicating it as B by A. Okay, ma'am. Now we go to the next one. Mutual inductance. Next heading. Mutual inductance. Mutual inductance.
Inner radius R1 inner radius.
R plus outer radius. Okay. Right. Next. Mutual inductance. See, this is speaking about that is the inductance property owned by the same coil. Right. Now mutual inductances. If suppose I have two coils, then here I have two coils. This is one which is bound with maybe I can say I'll give a supply voltage. Or ground volt, right? Anything. Suppose P, I am having a two coils that are linked together. Okay. So this flux that is when I give a supply voltage, what happens? Current will flow here. So because of this, the flux will be set up in the primary winding, right? In this coil. Not primary winding, in this coil. Right? When you talk about a transformer, it is the primary winding. But now this flux will get linked with the winding in the secondary or with the other coil. Right? This flux linkage is called as the mutual inductance. You understand? This is called as mutual inductance. Self-inductance means when I have this, the inductance owned by the coil itself. That is called as self-inductance. But if I have another coil nearby, what happens? This flux will link with the second coil. Similarly, the flux created with the second coil will be linking with the first coil. That is called as mutual inductance. You all understand? Yeah, what is self-inductance? It is the property of the coil itself, right? But when two coils are placed nearby, the inductance of one coil will link with the inductance of the other coil. That is called as the mutual inductance. Now we are going to derive the expression for mutual inductance. Let us see. Let us say I1 is the current that is flowing in the first coil. I1 is the current that is flowing in the first coil, and I2 is the current that is flowing in the second coil. I1 is the current flowing in the first coil, and I2 is the current that is flowing through the second coil. And we have two supply voltages as V1 and V2. Clear? Right? And the flux that is set up in the first coil is given as phi1. Okay? And the flux that is set up in the second coil is given as phi2. Phi1 and phi2. So clear? Right. So this mutual inductance M12 is given by N2. Right? N2 phi12 divided by I1. Let me explain. Wait. Then M21 is equal to N2 phi21 divided by I2. Listen, I tell you what is that. Now listen, get down and listen. Listen, M1, 2, that is the mutual inductance of the first coil and with respect to the second coil, which means that M1, no, so N1 is the number of turns. The current that was flowing in the first coil is I1. Because of this, the flux is created in the other coil, so it is Phi12. Can you understand? Similarly, here M2 will become N2 because of the second coil, the flux will be created in the first coil. So it is from that N2 Phi2 divided by what was the current that was flowing in the second coil? I2. Because of this current only, there was a flux linkage. Is it not? So you have to write it as N2 Phi21 divided by 2, because 2 is linked with the first one. So Phi21. First case, what is that? 1 linked with the second. So Phi12. And current, easy way of remembering, first coil means N1 I1. You understand? Second coil means N2 I2. That's it. Clear, students? This is about mutual inductance. Repeating, this coil, when I am having a current going through this coil, it will link with the other coil. That linkage is called as mutual inductance. When a current is flowing from the first coil, the flux linkage in the second coil is given as Phi12. Because of the current in the first, there was a flux linkage in the second. Okay, now second case. When there is a current in the second coil, there will be a flux in the first coil. So because of the current in the second coil, there was a flux linkage in the first coil. So that is given by second coil to first. Here, first coil to second. That's it. Okay, that is how you have to remember. Okay, this is called as mutual inductance. Take it up. And normally this mutual inductance M12 will be equal to M21. M12 will be equal to M21. Okay, then same amount of current is flowing in both the coils. Right, can we solve a problem? Right, take it out. Calculate a problem. Calculate the inductance of a solenoid. 8 centimeter in length, 2 centimeter in radius, 2 centimeters in radius, and mu r is equal to 100. Mu r is equal to 100 and 1000 turns. Okay, I am repeating. Calculate the self-inductance of a solenoid with 8 centimeter in length, 2 centimeter in radius, having mu r is equal to 100 and n is equal to 1000. How do you calculate the self-inductance of a solenoid? What is the formula for the inductance of a solenoid? Go back. N is equal to N square mu A divided by L. Right? Take it out. L is equal to N square mu A divided by L. Capital L is equal to N square mu A divided by L. What is mu? Permeability. But here mu cannot be given. Is the value of mu directly given? No. What they have given? Mu r. Mu r is nothing but relative permeability. So what is mu? Mu is equal to mu naught into mu r. I have told you already, Mama. Mu is equal to what is that? Mu naught into mu r. What is mu naught? Permeability in free space. Okay, permeability in free space. So mu is equal to mu naught into mu r, which is permeability in free space multiplied by relative permeability of the medium. Can you all understand? So you can just substitute and find out. That's it. The answer will be given. A. How do you find out A, ma? How do you find out A? Is the value of A given? No. It is told that it is a solenoid. So what will be the value of A? Area of a solenoid, pi r squared. It will be pi r squared. Can you all understand? So A is equal to pi r squared. R value is also given in your problem. Directly you can substitute and find out the answer. Right? Try for N and give me the answers. N is equal to. Give me the answers fast. I repeat. What is permeability? What is the permeability in free step value? Anybody? That is epsilon. What is mu naught? We have solved. Where there is the value, you will get yes, no, we have solved. Mu naught 4 pi into 10 power minus 7. No? I've got it under there. Taken the class. Mu naught is yes, take it out. A is equal to pi r squared. Mu is equal to mu naught mu r. Right? Mu naught is 4 pi into 10 power minus 7. Mu r value given in the problem. What is the value of mu r given? 100 after. Let's substitute all these values and find out the value of here. Quick answer. 4 pi into 10 power minus 7 I told you already. Go back. Go home. Got it answer. Yes, answer for N. Pass. Get 1 point. I have got 1.974. Anybody has got that answer? Centimeter. Our radius is given means centimeter or meter? Centimeter. Convert everything into meters and proceed. All the values are in centimeters. Convert it into meter and proceed. 8 into 10 power minus 2. 1.974 Henry. Okay, correct. 1.974 Henry. People are getting the answer. Centimeter to meter you would not have done. Check. 1.974 Henry. Okay. Shall we go with the next topic? How many have got the answer? Yes? Right. All of you got it? 1.974 Henry. Not take it out, take your answers at home. Shall I go to the next one? 1.974. N is 1000. N is 1000 plus is given. N is 1000. A is pi r squared. R is 8 centimeter. Okay. L is 1.974. Go to the next one. Magnetic vector potential. Next heading. Some more problems to be solved. After taking all the topics and solve the problem. Okay. That is that one. So solve all the topics and then we'll go to the problem. Okay. Right. Now, vector magnetic potential. Next one. Vector magnetic potential. Next, why we are using this magnetic vector potential is to find out the current density. Find out the current density. Show the next, the last one. Next you. What's your name? Kishore Raja. Bhuvanesh. No, not Bhuvanesh. Next one. Stand up. Tell me what we are going to find out. Stand up. What are we going to find? So what is that? B is equal to del cross A. Okay. So curl of magnetic potential, curl of magnetic vector potential is equal to the current density. Is equal to the current density. So what you will get curl is del cross H will be equal to J. Del cross H will be equal to J. And what we know regarding B, B is equal to mu H. So what is H? H is equal to mu B by mu. I am going to bring that here. Del cross H will be substituted as B by mu, that is equal to J. Del cross B by mu is equal to J, or B by mu naught is equal to J. Right? So del cross B is equal to mu naught into J. Del cross B is equal to mu naught into J. Right? So del cross B can be written as del cross. What is B here? What is B here? Del cross A. Right? So B del cross A, that is equal to mu naught into J. This is again del cross A. Anybody knows the expansion of this? No, not matrix. Any other formula you know? Alright, check whether you have learned this. Minus del squared A. Are you aware about this formula? The data. Del of del dot A, see, minus del squared A, that is equal to mu naught into J. Mu naught into J. So from that I can find out J. J is equal to 1 by mu naught del of del dot A minus del squared A. If they are asking you to find out the current density, you can find it out by using your magnetic vector potential value. The magnetic vector potential value is given as A. When you understand, let's solve problems of that, then you come to know why we need this. Clear, ma'am? Okay. Shall we go for a problem? Take it. Alright. Take it out. Shaktivel. Right, take the problem. At a point P of x, y, z, at a point of P, x, y, z, at a point of P, x, at a point of P, take it in bracket, x, y, z. X, y, z. The components of vector magnetic potential A, vector magnetic potential A, are given as A suffix x. A suffix x is equal to, sit down Kishore, is equal to 4x plus 3y plus 4x plus 3y plus 2z. Okay, and A suffix y is equal to before. Ax is equal to 4x plus 3y plus 2z. Second one, right. Ay is equal to 5x plus 6y plus 3z. Okay, and Az is equal to 2x plus 3y plus 5z. Determine B, capital B. Okay, what is B? Magnetic. Louder. Magnetic
flux density.
not field, flux density. Magnetic flux density. Determine B at a point P. And state its nature. And state its nature. Okay. Now what is given, ma? What is given in the problem?
Three equations are
3 equations are given. What are they? Ax, Ay and Az are given. Okay. Right. What they have asked you to find out? B. Right. So how do you find out B? Anybody?
B equal to
A it is a magnetic vector potential A. Is it not? Right. How do you find out B? Yes.
del into
Del
cross A.
cross A. We have to find out del cross A. So let us find out B, that is del cross A. Okay. So for that, del cross A is equal to, before that you can take it out. Given values you can take it out. B is equal to del cross A. Del cross A. How do you find out del cross A? Any idea?
Matrix.
Matrix. Very good. So del cross A will be matrix of, okay. What are the 3 components? Ax, Ay, Az. Okay. Then here, dou by dou x, dou by dou z. Okay. Then here Ax value. What is the Ax value given? 4x plus 3y plus 2z. Right? Then here 5x plus 6y plus 3z. The next one 2x plus 3y plus 5. That's it. Okay. Now we have to find out your value. How do you find out? No? Ax into dou by dou x of 5x plus 6y plus 3z. What do you have? Dou by dou x of 5x plus 3y plus 6z. 5. Right? 5. So here 5. Right? Then this minus. Right. Ax is what we will be having? Ax into dou by dou y of this term. Is it not? So dou by dou y of this term will become 3. Right? 3 minus dou by dou z of
3.
what is that? 3 will become 0. Right? Next plus ay. Minus ay. Dou by dou x of 5x. So what we have here?
A y and A.
Sorry. 2
Minus 2.
Correct? Okay, then let's say AZ 5 minus 3. So what we have it? All the terms become 0. We are having 2 times of is it not? That's it. 2 times of AZ. Okay? Dou by dou is the dog. What is the one? Dou by dou x of 2x plus 3y plus 12. Why is the one? A inside is AZ. Okay. Its magnitude is, take it out, take it out, take it out. Take the matrix. I will wait. Some more problems are there, huh? I will take portions. Tomorrow is not bad, huh? I may take one lab, so bring your notebook. Thursday also have your EMP notebook, CMM notebook. I will take it on you have to solve any problem, then only you'll be thorough and take some more hours so that you'll have thorough with the problem. Okay, right. In addition to my normal levels. Okay, right now. Its magnitude is constant in the direction of AZ. Its magnitude is constant in the direction of AZ. It is a conservative field. Its magnitude is constant in the direction of AZ. It is a conservative field. It is a conservative field. Okay. And I had to take one more topic of your third unit. Still I have got problem, students. I'll take, right? So first we'll cover all the theory part. Then I'll go with the problems. Okay, right. The next one is classification of magnetic materials. I think this you have learned already. And just a revise of your portions what you have already learned in your physics. Classification of magnetic materials. Dia, para, ferromagnetic material. Before going for that dia, para, ferromagnetic material, first the classification was based on the orbital magnetic moment, electron spin moment and nuclear spin moment. Okay, so based on that there was a classification. After that only they came to the classification of your